Welcome everyone. Today is January 16th, and this is another bi-weekly batch working group meeting. My name is Mati, and I'll be your host today. And on the agenda, we have one topic from Aser, who will be presenting us Sakara, a hierarchical cluster topology group scheduler plugin. So I'll stop sharing, and Aser, you should be able to take it over.
Okay. Can you see my screen?
Yes, we can see multiple windows.
Multiple things going on. All right. Good morning, good afternoon, everybody. My name is Asif Tantawi. I'm with IBM Research. I'm also associated with Red Hat. I'm going to present today. I would like to present today something that I've been working on for a while, and that is a scheduler plugin that is topology aware and places a group of pods at once. The reason I'm trying to socialize it with this group, even though it sounds like it should be a talk in six scheduling, which I originally wanted to, and I'm planning to have it discussed in six scheduling next week. But some members of the group, Aldo in particular, suggested that I should talk about it in this WG batch because of its relevance, especially to Q and the recent uh, work that has happened there as far as topology aware scheduling is concerned. So what I'm planning to do is go through two parts, right? So the first one is I'm going to give you a description of what this Sakara scheduler plugin is, and it is a scheduler plugin, and it does, as I said, group topology aware scheduling. So I'm not going to get into the details of how it works, but what is it and what does it do? And then I'm hoping to have a discussion on how does that relate to Q, especially with the task function, as I said, that was added. Are there any conflicts? Do they step on each other? Are there any benefits of having both? Does one help the other? And that kind of discussion. So I hope, an open discussion. So with that in mind, let me start give you an idea of what this plugin is. What does it do? So group of pods are homogeneous in terms of what the resource requirements are and how they need to be placed, typically a replica, a deployment, for example, or a pod group or something like that. In addition to some topological constraint, what is the topology? So when I talk about topology here, I mean a cluster topology, not a node topology. So the cluster has a hierarchy specifically, not any general topology. It's just a tree, the typical tree that people think about when they talk about cluster topology. Nodes at the bottom level, maybe the servers where the nodes are hosted, the racks and zones, and so on and so forth, the typical tree topology of a cluster. So what it also does, Sakara, is in addition to placing the pods, it might, due to priorities, preempt pods as hosts. And I'll get to that later on. I don't have to spend time about motivation and why that's needed. In AI training specifically, other HPC type workloads, you want the pods to be, for example, close to each other. You want them spread out in a certain way. You want a certain topology for a logical topology for an application or a job to run with good performance. If you look around for existing solution, if we didn't have this plugin, then we'll have to use other things, such as, for example, co-scheduling, which does a group placement for sure, but it doesn't have the topology, node resource topology, but it's about the node itself, the topology of the node, like NUMA topology. There are other things like pop topology, spread constraints, and what have you, but they are very limited compared to what I'm going to share with you. Uh, There is also, I should mention, the task function that's in queue, but that's not a schedule. So that's what that's the goal of this plugin. Of course, there are things that are not in scope. For example, how you discover the cluster topology, how do you manage it, what happens when it changes, and so on and so forth. That's not part of the scheduler. Migration of pods is not. Groups being elastic and the change size currently are not handled by this version of the plugin. The plugin, because it needs to be fast, uses heuristics, which I'll share with you, as opposed to more, solving an optimization problem, which it is. But we don't want to spend too much time on placing those pods and solving an optimization problem, so we rely on heuristics. And of course, people can add optimization algorithm if they wish to do so. So let me go through a couple of examples uh, just to show you what this thing can do. Hope I can move this. All right. So here is just this. I'm going to story of A. Okay. Uh, we have a certain cluster as you see down here. It's a tree. These rectangles are, I don't know if you can see uh, my mouse, but in any case, we have 9 nodes down here in this cluster. There are there are 3 racks in the cluster, and there is this root. So they are distributed equally, 3 nodes per rack. And the gray stuff here is how much load is already allocated. So these are pods already allocated. Okay. Suppose we have this group of pods in green that has 8 pods, these little rectangles, and the user specifically asked those 8 pods to be placed as the partition. There are some group constraints which I will share with you. One of there are pack, spread, partition, range, min, max, factors, things like that. Okay. So it's not just a simple packing. Okay. So at each level in the hierarchy, the user specifies what is the policy for placing those pods at that level. So at the node level, it says pack at the rack level partition to. What does that mean? So at the rack level, spread or break those 8 pods into 2 partitions. How big is each one? Hopefully about equal. So if 8, then 4, 4. But if it's 3 and 5, that's also okay. So it's just you could also have a soft constraint or a hard constraint. So now the default is soft constraint. So partition it 2 ways, and the pods that land on a rack at the node level, I want them to be packed. So the 8 ideally would be spread 4 and 4, 4 on each rack. And within that rack, ideally, I want all 4 pods in that rack to be placed on one node, if possible. So this is what happened in this particular case. The 8 got split into here are 4 that landed on rack 0, the other 4 on rack 2. And within each rack, the plugin tried to do its best. So it was able to pack all 4 on one node here, which is great. For rack 3, it couldn't, so it placed as many as possible on one node. So it got 3 on one packed, and the leftover was placed in here on node 7. Why didn't it go to rack 1? Because if it did, it would have it wouldn't have been able to pack anything, as you can see here from the available allocation. It would have been spreading 2 and 2, but 3 and 1 is closer to what the user asked, which is pack. Hope that's clear. So let's move on to the second example. Here's another example where I want, it's a different arrangement. I have a cluster of 7 nodes, and the nodes are VMs in here. The server is like the host. So these three nodes are hosted by server zero. These four nodes, three, four, five, and six, are hosted on server one. And that's all there is to it in this hierarchy. The group to be placed is consists of six pods, and the ask is again at each level. So at the server level, I want them all packed. So ideally, I want all six to land on one server. Within the server at the node level, I want them spread out for some reason. Could be performance, could be reliability, availability, what have you. But I want to specify a range, and the range is 2, 4, meaning a minimum of two and a maximum of four. Okay, so all six here got packed on server one and spread out, not too thin, so it's not like one pod on each node. It has to be at minimum of two and no more than four due to congestion, for example. So it got spread out down. So these are the kinds of things that Sakara is designed to solve. Okay. So far, so good. Any questions? All right. So I think you got the idea. So let me show you how does the user specify these directives? So as far as the topology itself, how do you describe the topology to Sakara? Topology is the tree. There are many ways of doing that, obviously. So in this particular case, I want the easy way, which is defining in the config map. It could also be defined in a custom resource. It could also be defined in other ways. For example, each node would specify the path from the node all the way to the root as node label. So there are various ways of doing that. There are pros and cons. As far as, for example, when the cluster topology changes, what is the cost of doing it one way or the other? Um, Nodes get added, subtracted, moved, rag. In network, for example, if the topology is based on networking, got reconfigured. So things like that. Okay. But in this case, I made it simple in one place, this config map, which could be updated, patched, changed, that describes the topology. And the topology is nothing but a tree like that. So it's, in this case, would be going down recursively from the root. This is rag zero, and in rag zero, there's this thing, and so on and so forth until it's the leaf. The leaf has no more children. Um, Now, in addition to the tree itself, I need to specify the names of the levels so that the user can say at that level, at the rack level or at the node level, I want things to be placed in a certain way. Okay, so that's the leveling. We'll get into the discussion of tasks. So in tasks also same thing happens. You need also to specify those levels. Here I have the resource names. This is kind of extra really because if I don't specify any resource names that it should consider, the scheduler plugin should consider all resources, CPU memory, other resources. But if one is specific about a subset of the resources that would be specified here. I'm not going to spend much time on that. So that's how the topology is described. Now, as far as user is concerned, how does the user specify the group and the pods in the group? What do they need to say that they belong to a group? So there are various ways of doing that, obviously. So again, in this example, I'm going with the easy one with the config map in which you specify all the specifications of the group. It could also be a custom resource that does that, or it could be something that already exists. For example, pod group. We know all about pod groups that the co-scheduler does, and Sakara would use a pod group if this config map, for example, does not exist. But you won't be able to specify a few things that are specified here. So how does the group is specified. The specifications are obviously the name, how many pods in the size of this group, the priority of the group, and more importantly, how it needs to be placed. How it needs to be placed, as I showed you in the example before, it goes down like that. For each level, the type of the, the constraint. So we have, as I said, we have spread, we have pack, we have also a spec here that is it hard or is it soft? Um, in addition to spread pack, we have a range, we have a factor, so you can say I want them factors of 2 or 4 or 8 or 5s or whatever. Partition, um, that's what I remember at this point in time. Okay, so that's how you specify the group. The pods themselves, they need to say which group do I belong to. Okay, so right now it's a label, and the pod group will also be a label, and obviously the scheduler name. That's all one. That's all the pod template has to say. So far, so good. So if you don't have any question, this is just a quick example of how things got placed in this particular case. Okay, so in this particular case, which I showed here, group has 6 pods spread on rack and pack on nodes. Okay, so this is the cluster, has this particular topology, 4 nodes, 2 racks, they are like that. There are 6 pods spread on racks, mean hopefully 3 and 3 on each rack. Pack on nodes, meaning hopefully all 3 would land on the same node. And that's what happened in this example. Doesn't have to be that way if things are soft. They have to be this way if it's hard. If it doesn't fit, they are all pending. So they got placed that way. In the logs, you will have, how things got placed. But not only in the logs, the or the actual placement, the what's called the logical topology of the application or the job is also written back on the in that config map that has the group spec. So that because sometimes the application needs to know how it's distributed so it can configure itself, for example. And in addition, to make it easy to configure, we also have a rank, what's called a rank. So a rank is 0, 1, 2, 3. So the pods got rank 0, 1, 2, 3, and so on and so forth. Who gets a 0? Let's say some node, some pod in this application, if it's a master worker kind of arrangement, then the master could be the 0, get the rank of 0. And then depending on how they got placed, 1 is the closest distance-wise in the tree to 0, and then 2 is closer to 1, and 3, and so on. So it computes the distances, and it would give the rank so that, again, the application can configure itself, as well as the pods themselves get that rank as a label. Okay, so the pod itself might read that label rank, maybe use it as a custom as an environment variable that it configures itself. Okay, so that's the example. These are some group constraints that I share with you. Pack meaning put them all together as much as possible, spread them, um, partition them, min max, and a factor of. So if no questions, let me move on to preemptions. What if, so in this scenario, I have 2 groups that are already placed. One is priority 0, one is priority 1, and they're placed that way. Okay, the 2 groups. A new group came in, is A3, okay, with a high priority. So it preempts, Sakara would preempt um, some groups, enough of them so that the high priority would fit. And it did that, and it preempted the 0. In this case, it was just one group that was preempted. Preemption here is at the granularity of the group. The whole group either stays or goes. The preemption algorithm that currently exists in Sakara is pretty simple. Could get complicated, but we don't want to get it complicated. So it's very simple. Look at all the lower priority ones than the one you need to place. On paper, remove them, remove all of those pods, place the new one, and then try to place back the ones that were removed in order from higher priority to lower priority until you can't fit them back, then they are victims. And that's how it works. Could it be better? Yes, it could, but that's how it is for now. And then we have the implementation, which I will spare you from that. Um, any questions about the plugin itself before we get into discussion of what does it mean and how does it work and if there are any conflicts with Q?
Go ahead, Martin.
Uh, I believed in the APIs you used config map instead of CRDs. Uh, why so? Why did there the designated API that could be validated more easily is not used here?
I agree. As I said, for simplicity. Now, if we introduce a custom resource, that will have to be carefully done because there are already some custom resources, as I said, that define a group, such as a pod group. So my suggestion would be to start with, instead of inventing something new, is to take the pod group and maybe modify it because we need more specs. Then we need to specify. Uh, oh, you're talking about for the group, right?
I'm talking about both, I believe.
Yes. So
So
for the
here
group,
you have group specification and constraints in serialized JSON, and in the cluster specification you have cluster layout, also like serialized JSON. So
yeah,
my question would be why this approach?
yes. That's right. So as I said, for simplicity, but for as far as the group is concerned, yes, I would start with something that already exists instead of creating introducing something new, such as a pod group or something else. I don't know, maybe a pod set that Q uses. But the some other constraints, some specification have to be added. So that will involve changes.
One additional question: if you could switch to the slide with cluster configuration, please. Uh, yeah, that one. Uh, why not base this tree definition on node labels? So, a couple of cloud providers already put topological labels on their nodes. Plus, there are tools like Topograph that also try to mm, provide these labels.
Yes,
And using custom config basically makes your life a little bit more difficult here.
yes, I agree with you. So yes, if you have labels and there are tools already, then fine, be it. Let's do that. As I said earlier, labels is basically you take a leaf and you find the path from the leaf to the root. These have to be on labels on that node. That's all there is to it. And as I said, there are pluses and pros and cons as far as the dynamic changes to the tree itself. What does it involve? But if there are tools that do that, then fine, we can use them.
Okay, cool. Thanks for the answers.
I had also a question. Maybe it has been asked, but is Sakara scheduling something dynamic? So I was mentioning in the chat, like if for some reason topology changes, like a node crashes, something like that, and that the node needs to be rescheduled, will Sakara take this into account, or it will remain yeah, unscheduled?
Right. So right now it does not reschedule. The topology could change, obviously dynamically, but when the group is scheduled, the group, Sakara would work with one topology, which is the topology that existed at that time, and it work with that, places things uh, given that topology tree, but will not
Yeah, good.
migrate pods or anything like that.
I have a question about like the algorithmic part.
Yeah.
So you mentioned that you have this knobs to control like different kind of algorithms at different levels, like spread versus pack.
Yes.
What is like the for the spread, especially like the reasoning that you introduce,
Yes.
and because we were actually thinking about similar things, and
Yes.
we are like I'm developing the feature in Q, thinking about sort of balancing the packing, but also to reduce fragmentation in the cluster. And we are like thinking how to balance different aspects of the algorithm. But on the other hand, let's say putting a lot of knobs to the user also might be a little bit hard. So maybe a little bit open question, but what is your thinking about, let's say, how to design like the algorithm for balancing fragmentation and packing, but on the other hand, did you consider something more autopilot like without the knobs per level?
Right. So that's a very good question. So for the algorithmic piece, we have something it's an open source that's called ChickScat. That that has the implementation of the algorithm itself. What does ChickScat come from historically? And it's published in a paper. That's where the algorithm was published. So it came from when we were working in the HPC world and really placing VMs in the data center. But the problem is the same. So the algorithm itself is generic. It's not about, specifically whether it's a VM or a pod or whatever. But it was originally developed for placing VMs in a data center. And so we wanted those flexibilities at the various levels. I don't have time to go into the algorithm, but we could do that if you'd like, maybe some other time. But this is where the paper is, and that's where sorry, and that's where the code is for this particular algorithm. How does it work? I don't know if I have a picture here that maybe I can just quickly. Um,
Can you share the
I'll say
link?
it in words. So I'll say it in words. So it's all about traversing the tree. As I said, this could be formulated as an optimization problem that is combinatoric. It could really get complex if you have a very large tree and a very large group to be placed. But instead of solving it optimally and finding the optimal solution, which could take time, we have heuristic, and the heuristic is basically on how you traverse the tree. If you're working on, I'm not sure if you come from the queue or task work, which is pretty straightforward because you're packing at all levels. So you just order things in one order. But with this algorithm, it depends on what the ask is, what is the policy that you need at each level, and you traverse and you order the nodes at that level given the constraint. So for example, if it's about packing, then you order them in some decreasing order, whereas if it's spread, you order the other way around because you want them as thin as possible, whereas the other one you want to put as much as possible. And so it's all in how you order things and how you visit the nodes. In the algorithm, we do not go back and uh, revisit what we've already done. So if we already visited a node, let's say rack 0, and we placed 5 pods already of the 16 pod group and moved on to rack 1, we don't go back and change the, oh, we should have placed 4 instead of 5, because otherwise it gets too complicated. So it might be suboptimal in cases, but it's quick. And by quick, let me qualify quick. Uh, Let me qualify quick. These are measurements. So this is just the algorithmic piece. So this is not Sakara and looking at the current state and so on and so forth. This is just when you formulate the placement problem and you solve it. Talking about milliseconds as far as, so we changed the number of servers here in the thousands, and we changed the group size in the hundreds, and we're within a millisecond or 10 milliseconds to place the whole group. And we're happy with that. We don't want it to be much longer than that. So I hope I answered to some extent your question.
Yeah. Thanks a lot for the comment. So first of all, the reference is quite interesting, and second of all, right, as you say, maybe in Q with the design to only support pack, we had a little bit simpler algorithm, but also we are not super satisfied due to the possible fragmentation, and we are still looking for some sort of ideas for improvements. So thanks for the reference as a point of inspiration for sure. I also before I have also two questions. Like, what do you do with pod affinities? Let's say if they are specified, do you ignore them or reject or support somehow?
No, we don't ignore. We do not ignore. This is a plugin, so it could exist with other plugins in the Kubernetes scheduler, in addition to what the default scheduler is doing. So it's just a plugin. It does what it's doing. Now, once Sakara as a plugin assigns a node to a pod, right? It will give it a very high score. And so on the score extension point, it will give it, let's say, 100 for that selection. But any other selection would give it a 1. So that the other plugins, as well as the default scheduler thread itself, um, will have a say on how a pod is placed. I don't know if I'm making myself clear, but no, they're not ignored.
Okay, thank you. And if you have a job with multiple pod sets, like for example,
That's a good question. So currently Sakara works with one group of homogeneous pod. So if you have, let's say, uh, two sets, let's say 2 pods in a master and 4 pods in a worker set, if they're all asking for the same amount of resources and they all have the same constraints for placement, then they would make a group as far as Sakara is concerned. If not, then there are sets of sets, and we know how to deal with that, but we haven't done it yet. But that's a future thing. It's a to do.
Okay, thank you.
Thank you. All right. So since we don't have much time, I'd like to spend maybe.
I have a question.
Yeah.
I can. Sorry, I don't know how to raise a hand here because I don't see a button. But So we met on 6 scheduling meeting, but we were just two of us. So I'm Dominic from
Oh,
I'm a
okay.
scheduler.
Hi, how are you?
Right. And I have one comment and one question. So a comment about preemption is actually I'm exactly right now working on exactly the same concept of preempting pods on different nodes. So the what you described is something that I have in mind and something that can exist even like without the plugin. It can be a generic preemption approach. It it is the idea that haven't been discussed yet and raised, but just this is what I wanted to comment on. Uh, the question, however, I have regarding the overall topology approach is because I may not know all the details how Q does that, but have you compared those two approaches and how they compare and whether the Q cannot do the work that is needed here?
Okay, so I think your question is about comparison, kind of, between how Q does things and how does Sakara does as far as
Right.
topology
And
is
is it
concerned.
and if they do the same thing, is it a replacement? So
Yes,
you
that's
could use
exactly where I
Q.
was going.
Mhm.
That's where I was going with the discussion. So that's the next segment. Now that we talk, now I hope you have an idea of what this Sakara plugin does. So let's talk about queue and task function and how does it relate to Sakara? Are they conflicting each other? Are they helping each other? So I'm not going to spend much time because you guys are the expert. I'm not on queue. So, but the way I look at queue is, you have all those concepts. Um, my point is that basically queue is about obviously queuing workloads, preempting, dispatching, deciding when to dispatch a job, and so on and so forth. But as far as placement, meaning placing the pod sets on nodes, that is out of scope for queue. What's in scope, my understanding is there are placed or assigned flavors. The mapping from flavors to the actual cluster of nodes, for example, is handled through the way it's implemented through labels. It doesn't have to be that way, but it's just handled through labels. That nodes label themselves or color themselves with these flavors. Okay. And depending on what you has decided for a pot set, as far as its assignment is concerned, it will say this will go on this flavor. Okay. And whichever node has that flavor could get it. Who's the final assigner really of a pod onto a node? Not queue, it's the schedule, right? So there is some separation, which is really nice. There is a separation between what actually is the cluster, so the nodes themselves, and what queue is doing up here. I hope I got that picture right. So for example, the resource fit, whether a particular pod fits on a node, is handled by the scheduler and not queue, right? Resource, the amount of resources on a node is not in really handled by queue because queue is concerned about quota. So there are quotas assigned to flavors, and quotas need to be, of course, assigned in the right way, and so on and so forth. But I don't want to get into discussions of internals of queue. But at high level, it doesn't do the resource fit, for example, that the scheduler does. It doesn't look at conflicts, as was mentioned before, and affinity, and so on and so forth. Okay, so but the final node assignment of a pod to a node is done by the schedule. When task was introduced, and correct me if I'm wrong, which currently does, as was mentioned before, it's a pack. So I'm calling it a simple pack. So pack at all levels. if not at all levels, actually, I'm sorry. So a user says the spot set needs to be packed at the rack level, which means that rack and above it's already packed. Below rack is it could be anything basically. If you go all the way to the leaves to pack, which are pack on nodes, that means you pack on everything on all levels. And so if you say pack on rack, anything below a rack is basically going to be chosen by the scheduler and not by the task function. Because task at the end of the day, it just assigns flavors. And those topology flavors, again, there are node labels. So nodes paint themselves with a certain flavor. Now, because task has to deal with, has to be concerned with the topology, now the separation, this conceptual separation between what the cluster is, especially the nodes, is, in my view, is compromised. It's not there anymore once task is in, because now it specifies in a way nodes that pods go to. Okay, we can debate, doesn't matter. It's not. I'm just making that as an observation. It doesn't talk about Sakar. So having that, let's talk about Sakara and Q. Can they coexist? Meaning, so if you run both of them, what's going to happen? Are they harming? Is there any conflicts? Harm. That's what I would care about. If none, then they can coexist. Are they exclusive? And the question was asked before. Do we need only one of them? So if we have one, do we need the other? That's the question. And what I call mutualism, could they be helping each other? Could the function of, could TAS be helped by Sakara, or could Sakara be helped by what TAS is doing, or otherwise? I really don't have very good answers. So I'm hoping we could have discussion. If not, in this meeting, maybe we'll continue online or what have you. But I have some thoughts. And let me share that. I may be totally wrong. I may be correct. I may be partially correct or partially wrong. All right. So let's take these one at a time. Coexist. Can I have Q and Sakara running at the same time? So task function especially. Okay, so if task is running, that means the workload is very specifically batch workload. Workload that is not will not go through queue. But if it is, and it's running, and we also have Sakara as a plugin. I mean, nothing that task should not doesn't need to know if Sakara is or is not running as a part of the schedule. It doesn't sound that there's a conflict. So let me clarify that. So what I'm thinking is, so task assigns flavor, it assigns node flavor, but those assignment, because the way it decides where a pod set should go, right? It does take into consideration, I didn't spend much time with this picture here, but you see the resource fit function that is down here moved up to task. So task now does the resource fit function on a tree. It would do that on a node if the level that is specified is pack on node, but it does have to look at the allocatable for resources of all nodes. It will have to percolate all of that on the tree. And whenever it assigns pod set, it will have to do the resource fit for that, right? So after doing this resource fit, it will assign maybe not a node, but a group of nodes if the pack is not at the node level. Now, once that's done, that's restricting what Sakara, if Sakara exists, a little bit, because now you really narrowed it down. So if you being Q, if Q narrowed it down to the node level, then Sakara has nothing to do. If you narrowed it down to, let's say, a Dirac level, then it has a little bit, maybe, but not really much. Okay, so it's a lot of restriction. This restriction, so once the pod set is presented to Sakara as a group, and if it cannot place it given the constraints, given the current state, because the state may have changed, or some other constraints that task did not consider, for example, pod affinity and other plugins that are running in the scheduler, right? That now the group cannot fit, then it will be pending as a group if Sakara is handling it. And that may cause you to do things like, well, we'll requeue the workload, we'll react to that group not being running. So it's still in the pending state. So there might be some interaction. So I mentioned a few examples here. So let me move on, just for the sake of time, to exclusivity. If we have one, do we need the other one? It seems like only one suffices for batch workload. So any workload that is not batch, that is not going through queue, and you want the topology placed, then you need Sakara for sure. If the workload is going through queue with the task function in there, do you need Sakara? I claim no. If the workload needs to be placed only in the simple pack way. If it's not simple pack way, then you need Sakara. But then task will have to be a no-op, or that task needs to be enhanced in case we need the workloads to specify other policies than pack, as I showed before. Mutually, could they help each other? I think we talked a tiny bit about that, which is we touched upon the algorithm, right? And we said that task has an algorithm, which is simple and it makes sense because it's solving a simple problem. The problem that Sakara is solving is a little bit more complex, and it solves that using this algorithm, which could be used by task, but it will be like you don't need this kind of elephant to solve the problem that task is solving today. But potentially, if uh, we add more functionality to task being, needing to place things in a richer way, then maybe the same algorithm could be used. I don't see any reason why not, but it could be. Um, Another thing that maybe is also worth discussing is whether Sakara could be run as a library, could be in a dry run kind of a thing by Q. So Q is really concerned about whether this workload could fit given the constraints, including topology constraints, or not, versus this other job. Because I have multiple jobs, multiple workloads in the queue. I just need to figure out is it gonna run? Is it schedulable or is it not? That's all I care about. I don't need to place it. All I need is a binary thing. Is it schedulable or not? Don't tell me exactly how it's gonna be scheduled. All I care about is the binary. And so the question is, could Sakara do that? Um, so I tried to maybe put it in this simplistic, if you will. Like, so if I have Q or not, or if I have Sakara or not, what would happen? Um, so obviously, if you have neither, right, and you need to place workloads that are topology dependent, that's definitely no good. So we need some form of topology awareness. The topology awareness supplied by Q is for batch workload. And obviously, because Q is about quota management and it's queuing things and preempting things and so on and so forth, that's great. So far, it's only packing. If you use Sakara without Q, if Q is not there, or that the workload is not a batch workload, you have some service a collection of simple pods that need to be placed in a topological way. Then they will be dispatched as, so we can dispatch these general workload according to a richer set today um, for specifying topological constraints. And obviously the thing you get with Sakara is a group scheduler. So it's all or none placement. So all the pods or none of the pods in that group will be placed. If you don't have, I'm sorry, if you don't have, uh, if you have queue without Sakara, you don't get that function. You don't get the groups function unless you use another plugin such as the co-schedule. So these are some thoughts, and I'm going to stop here. Now we can throw your tomatoes and eggs or flour.
Go ahead, Martin.
Okay, so definitely no tomatoes flying today here. It's very impressive work. A couple comments here. First of all, about queue mechanics. So we suffer deeply because queue doesn't have built-in scheduler code. So we suffer when we admit workloads, even without topology or scheduling, because we admit it based only on a quota, and that could be a false positive. In topology or scheduling, we are getting more into that problem because when we are assessing and evaluating a particular topology, we need to make a decision whether the workload would fit there or not. And the more closely we look at a particular topology, then the more precise the decision eventually will be. So imagine that a user asks for rack. We just check whether there is enough capacity in the rack. Well, we compare two numbers, we admit the workloads, but it appears that all of the nodes are too small and we fail. So we need to go deeper in that picture so that ideally to the node level and validate whether these pods from the workload could actually fit into the nodes to make sure that if we make a decision that we admit the workload, then it will actually be started. Otherwise, we admit something, it's half scheduled, then we need to back off and bad things happen, particularly cluster underutilization. So the current idea is with topology hour scheduling to introduce as much of scheduling code into queue proper and to admission code as possible so that the decisions that are made for topology hour scheduling are as precise and as correct as possible. Right now, we assign the lowest level topology in topology hour scheduling. For that, we evaluate it at this moment, and which is kind of basically like a Kubernetes node. We don't assign the node, we leave it to scheduler, but it's a little bit of artificial step. Ideally, we should probably close the gap and do all of the things in queue. So proper node evaluation, proper matching, all of these things should probably eventually land in queue, because only then we could make a meaningful decision that the workload would fit there. Moreover, if there are two entities working on the same set of nodes, race conditions can occur because pods upon job admission are not created immediately. There might be, I don't know, 1, 2, 3, whatever seconds delay between the time when we admit and the time then the pod is actually being created. And if there are multiple things operating on the same set of nodes, then the separate scheduler or whatever could make a decision, hey, I want to place this workload coming on different way on this node. Q may decide, well, this workload fits into that node, and eventually both of the assignment will fail, and Q and the other scheduler would have to recover from this race condition failure. So all of that combined probably mean that in longer run we need to meld together Q and kube scheduler, so that the whole decision from the topology point of view would be done by a single component with the full knowledge and full responsibility for the node. So no, there would be no race conditions, and also things like preemptions would be done with the appropriate context. For example, if you submit a high priority job using Q, then these priorities only play inside of individual queue. Probably they should not affect workloads from the other queue. So that whatever is executing the actual preemption or reclaim or whatever should be aware of which workloads belong to who, because preemption also should be precise. We cannot kill the workloads that is totally unrelated and should not be preempted in favor of some other workloads. So all of that things basically led us to thinking that to do topology aware scheduling, we probably need to do everything in one place. So both evaluation, both scheduling, both node scoring, both topology scoring, which we don't have, like while one rack is better than the other for scheduling, all of that things should somehow be combined into a single decision. Hey, this workload can be admitted, it is placed on this topology, and pods go to these particular spaces. That's like one scheduling decision. And if we are trying to separate them, then we are losing functionality and also oftentimes correctness. So I'm not sure exactly how we could proceed right now. I see definitely a lot of value in Sakara. Maybe we could think how we can take, I don't know, parts of algorithm here or there and mold them together in one piece so that we use benefits of all of that and combine it into a greater product. Can they work separately? Maybe. However, the end user would benefit to much larger extent if they work together. If the whole scheduling process was made in one component with all information in place, with correctness, no race conditions, and proper placement. That's my couple cents. We run a little of time, Olivier, maybe.
Right, I was about to ask if Oliver to squash in because we're already 1 minute past.
So give me just 10 seconds, right? So 10 seconds. Okay. Yes, we need to discuss this. And just as a reminder, topology aware scheduling is one aspect of this. The other aspect of this, question, Marcin, you just expressed is fractional GPU allocation and in general, dynamic resource allocation, and what it means to maybe do this decision in one place, but really have a way to compose different decision engines, not just the topology, but also, for instance, in /life for fractional GPU allocation.
Mm-hmm.
Okay. So with that, I need to cut us off and be respectful of everyone's other time. If required, we can continue this topic next time. Thank you very much all for today, and see you next time. Bye all.
Bye.
Thank you, sir.